What's up, everyone? This is LeetCode 416, partition equals subset sum. So we're given an input in array nums, and we have to return true. If we can partition the array into two subsets such that the sum of the elements in both subsets are equal to each other, or false otherwise, right? So basically, we're given this array, and we have to basically partition it into two different subsets, where they have to basically equal each other, right? So our input here is 1, 5, 11, 5. And we can partition that into 1, 5, 5, which equals 11, and 11. And you can see that these two are equal to each other. Here, right, we have 1, 3, or 1, 2, 3, 5. And we can't partition it into anything to where we have two subsets that are equal to each other, right? The sum of the elements in each one. So I'm going to go to an illustration just to kind of give you some kind of insight into this problem. Okay, so one thing you should notice about this problem is, think of it like this, right? Like, let's take the sum of this, right? So 1 plus 5 is 5 plus 5 is 10, plus a 1 is 11, then plus this 11. So the sum of this entire array is 22. Okay, so what we basically have to do is, imagine we have 22 tennis balls, right? We have to basically partition it into two subsets, right? So it's like having two boxes, right? So can we take these 22 tennis balls and distribute them in these two boxes basically so that they're equal, right? Well, yeah, we can, right? Because we could have 11 tennis balls in this subset or this box, and 11 in this subset or box, right? Because this is just example one, okay? So as you can see, yes, we can, right? So there is something interesting here, right? Which is that, what do you notice? Well, if we take the sum of everything in the input array and we divide it by 2, right, that gives us how much should be in one box, right? So we can use that to our advantage in this problem by basically taking the sum of the input array, dividing it by 2, and if it's an even number, that means we know that we can distribute it equally in these two boxes, assuming that it exists, right? What I mean by that, if it exists, and the reason I point out if it's an even number is because imagine if our, right, like, imagine if our input is something something like this, right? Let me cross this out, and let me add a 1, right? Well, if we have 1, 5, and 1, that's what, 7, right? Well, if we have 7 tennis balls, we can't equally distribute it in these two boxes, right? So the sum of the input array has to be an even number. If it's not an even number, we're going to run into issues, because how can we ever take an odd number divided by 2 and get an even result, right? That's not possible. So in order to basically sum up these tennis balls, right, and get this number here, right, when we divide it by 2, that better be an even number, right? Because that tells us how many tennis balls we have to put in one box, right? And we know that we can find, so when we do 22 divided by 2, right, we get 11, right? So we know we have to basically find some subset here that equals 11. And if we can do that, right, and we can find some subset that equals 11, we know that the other one naturally will exist also, right? Because again, we did the total sum divided by 2, right? So if we can find this a subset that equals 11, we know that there is also another subset that is also equal 11, so we can just return true, right? Now, if we can't find a subset that equals 11, then we have to return false, because, well, we can't partition our input array into an equal subset sum, okay? So let me delete this. Okay, so let's get started a little bit on this, right? So this is basically like a base, I guess it's like a base case check, kinda, right? Which is that summation thing that we were talking about, but I'll write a comment, right? So we're gonna say the sum of nums divided by 2 must be an even number. Otherwise, you can't have two equal partitions, such as if the sum of the input the input is like 7, right, or something, then we can't obviously have two equal partitions, okay? So let's take the summation of our input array, right? So we're going to do this. So that's the total. And what we're going to do is we're going to say if total modulo 2 is not 0, meaning basically if total is odd, then we have to return false, right? Because again, if we have 7, we're never going to be able to create two partitions that are equal because we have an odd number of tennis balls. So we'll never be able to have an even number of tennis balls in both boxes such that they're equal to each other, the amount in each box, right? Okay. Now if we don't encounter that, it means we have an even number of tennis balls, basically, right? I'm using tennis balls just kind of as like a just like an example. It's easier to picture in your head, but now if we have an even number of tennis balls, it means we potentially can partition them equally in both boxes depending on what our input is, and that's kind of what we're solving for, right? So our target is going to be total divided by 2, right? And I'll write a comment here. So we're going to say each partition must be equal to the total sum of the nums array divided by 2. So e.g., right, for example, for 1, 5, 11, 5, right, the total sum is 22. So 22 divided by 2 is equal 11, and 11 is our target here, right? Okay. Now, I'm going to show you two solutions. So this first solution is really, I think I saw it from NeetCode, but it's really elegant in approaching and understanding this problem. I don't think it's the most optimal, which is why I'm going to show you a second solution, but I'm going to show you this first one just because it's really easy to understand and wrap your head around this problem, right? Because this is a DP problem. You can solve it top down, bottom up, right? I don't know what NeetCode's solution is. It's kind of like bottom up-ish, but it's a little bit weird, but it's still really good. So I want to just show it, make you aware of it in case you haven't seen that video. But really, the gist of his approach is that we're going to build up to target, right? We're going to build up target, and we either take or don't take, right? So when we have an input like 1, 5, 11, 5, right, and we're building out a subset, we can either take this one or not take it, take this 5 or not take it, right? And to basically build out our different sums to see if we can find some certain subset that maybe equals up to target, right? And it's like the O1 knapsack problem, if you've heard of that, right? Or take or don't take, whatever it's called. You might have heard of it, maybe not. It's okay if you haven't. But the gist is really we're going to have a set, right? And we're going to iterate through this input. And what we're going to do is we're going to keep basically track of whatever element we're on, right? That's its own thing because that can be a subset of itself, right? But as well as like different combinations, like what is the sum of 1, 5? Well, that's a potential subset, right? So that'd be in the set. We could also have 1, 5, 11, right? Which would be 6, 17, right? That's a potential subset. So that would be in the set. And then we could have 1, 11, right? Like 12, that would be a potential subset. Or just 11, right? That would be a potential subset. And this will, and the point of the set really that will help us is that the set will prevent any duplicates, right? So for example, if we have like 1, 1, 5, 1, right? Well, we can take 1, 5, right? And put that in our set. But let's say we also skip this first one, but we take the second, we take the 5, right? That's also in our set. But let's say we take the 5, and then when we're going through the loop, we take this 1 here, right? 5, 1. Even though these are two different ones, the 5 plus this 1 plus this 5 gives us 6. But at the same time, this 5 plus this 1, even though these two 1s are different elements in the array, 5 plus 1 and 5 plus 1 is still the same thing, right? So when we do 1 plus 5 or 5 plus 1, they both equal 6. So we don't want to add both of those to our set, or we don't want to include both of those subsets, right? It's redundant. So we want to basically keep our set so that we can prevent duplicates like that, okay? So it's kind of a little elegant to use a set to solve this problem, right? And we have 0 here because this is really our base case, because we can always build up a summation up to 0, right? Because, well, 0 is kind of like a base case, like you can have a sum of 0, right? So we're going to say for I in range, right, length of nums, right? And, right, we cannot update the DP set while we iterate over it. So we use a separate set, and we'll call it next DP. Okay. So what we're going to do here is we're going to say for T in DP, right? And we're going to use next DP add, right? And we're going to take T plus whatever the element we're on, as well as just the element that we're on in the set, right? And we're basically going to overwrite DP by doing DP next DP. Okay, so here what we need to do is, so to understand this, right, we basically have some set, right? I mean, just think about this logically. Like initially our set just has the 0, right? Because it's a base case. So when we're iterating through this, right, let's say example 1, which is 1, 5, 11, 5, right? Our set initially just has 0, right? So we're going to do what? 0 plus 1, that gives us 1. Let's put that in our set. And then we'll add also 0, right? Because that's what T is. So we add that. Technically this doesn't have a 0 because, okay, we're taking next DP and building that out because we're on a new element and we want to include that as a potential like sum, right? And then we're overwriting DP with that. So technically I can just do it like this, right? So initially DP only has 0, right? But when we're iterating in this for loop, right, we're actually not looking at DP, we're looking at next DP because we can't overwrite or we can't update the DP set while we iterate over it, right? We'll run into problems. So what we're going to do, right, we're going to say for T and DP, right? Initially DP just has 0, right? So next DP, we're going to do 0 plus whatever number 1. Well, if we're iterating through this, right, we're going to be on the 1. This is our input array. So 0 plus 1, right? We're going to add that to next DP as well as whatever we're on right now in the DP iteration. So it'd be 0, right? So we'd overwrite DP of, or DP, we'd overwrite this and now we'd have this, right? And let's say then we move on to the next element, which would be a 5, right? We're going to iterate through DP. We're going to do what? T, which would be 1 plus whatever element we're on, which is 5. So 1 plus 5 is 6, right? 1 plus 5 is 6, as well as add whatever we're on in the DP iteration, which would be 1. So let's add 1 as well. Move on to the next element, which would be 0, right? So we would do 6, or not 6, sorry, 5 plus 0, so we'd add 5. As well as just whatever we're on in the current set, would be 0, right? And so, so far, right, these are the possible subsets we could have, right? We could have one that adds up to 0, 1, 5, or the combination of 1 and 5, right? D6. So you can see we're slowly building out the different possible subsets that sum up to something. And we have to check basically at the end of this, we're going to have a bunch of sums, right? Or different subsets. Well, we're really storing the possible like sum of all the subsets. So we have different subsets and we're storing their sums really. And so at the end of it, we're going to look in this set and we're going to say, okay, is there some sum that adds up to whatever our target is? And if that is the case, then we're going to return true, right? And of course, we will have that, right? So we're going to say return true if target in DP, else false. Okay, now I'm going to run this. I know this video is a little bit long, but again, these are just kind of these DP problems. They can be a little long. Okay, I messed something up. Let me see. I must have done a little syntax error somewhere. All right, sorry. My error is that this should be outside the for loop. Oh, silly mistakes. Right. Now, just to show you basically what our thing looks like when we're done, right? Let me just print the P. DP, just so you can kind of understand like all the different we're not actually printing the subsets, we're printing the sum of all the subsets we can make, right? So right, we have one, obviously we're always going to have 1, 5, 11, and 5 because those can be their own subsets, right? So we have 1, 5, 11, and 5. We could also have something like 1, 5, 11, which would be 6, 17. So we should have a 17 in here, right? We also could have like 1, 5, 5, which would be 11. And you know, what do you know? That's actually the one, that's actually a valid subset, right? So this, because this exists, we're going to return true, right? Because this is in the set and our target should be 11, right? So 11 does exist in our DP set, so we're going to return true. Okay. Now this is a little bit of a kind of interesting solution by NeetCode, so I do want to show it off, and I am giving him credit. Okay, it's really elegant. But I think the one-dimensional like DP array solutions are slightly more efficient. So I'm going to show that now. Okay, and those are a little bit harder to understand, but I'll try and explain it as best I can. All right, what's up everyone? Now we're back. Well, I'm going to show you this illustration of how we're going to solve this problem now using a one-dimensional DP approach. Okay, so we're going to have to create a DP array, okay? And it's a Boolean array. And the length of the DP array is basically whatever the target is plus 1, okay? So I have this example here that I just thought of, right? It's perfect because it'll help illustrate the DP approach more perfectly because the target is not an element in the array. Like, you know, like if you have something like, you know, like 1, 2, 3, right? You sum this up and it's 4, 5, 6. 6 divided by 2 is 3, right? If the target is 3, well, 3 exists as an element, so it's not that good of an example. This is a good example though because the target is 7, but 7 is not an element, okay? So it's a perfect example, right? So we have 1, 2, 5, 6, right? 5 plus 6 is 11, right? 12, 13, 14. Okay, so the sum is 14, right? That's an even number, so we know we can potentially make two partitions that are equal to each other, so we can proceed with this problem. So we're going to take 14 divided by 2, we're going to get 7, and that's going to be our target, okay? So we're going to use this to create our DP array, right? Remember, the DP array has to be target plus 1, that's length. We have to do plus 1 because we want to, well, we always have base case also. Kind of with DP problems, right? So this is our Boolean array, okay? Everything is initialized to false in the DP array initially, except the 0th index that is set to true, right? And the reason for that is because this is basically, can we make these numbers up from certain subsets in our input array, okay? Now we're assuming we can't make any of these numbers up initially except for 0 because of course we can always make the sum of 0, right? That's just like a base case. That's why that's set to true at the 0th index for this DP array, right? Now, I will say also, in the Grind 75, we did a problem previously, right before this one, called word break. That one's also a DP problem, and it's very similar in nature that we're using a DP array, and we're basically calculating stuff, and then we're returning the last index. For that problem, we have like a set of words, and we're going to see, and then we're given an input that's an actual word, and we have to see if we can use these set of words to build out an actual word. And if we can, we return the last index. So I recommend looking at that problem, that video. It's very similar to this problem in terms of kind of the approach. The problem is different, but the approach is very similar. Because we're in that problem, we're also using a DP array. So feel free to look at that problem. I have a video on it. So, anyways, so we create our DP array, right? Based on this target. Okay. So how is our algorithm going to work? Okay. Well, what we're going to do is we're going to have two for loops, right? In the outer for loop, we're going to traverse this nums, right, linearly, right, and hitting all these elements. And then at every step in that for loop, we're going to have an inner for loop that is going to iterate from wherever target is, right, from target up to, or we're going to iterate backwards, but we're going to go from target to nums -1, but that's not inclusive because of how for loops work, right? Also, this is wrong, by the way. I just noticed. My bad. I'm sorry if I confused you. This actually should be a little bit shorter because target is 7, so our DP array should be of size 8, but remember the 0th index counts as 1, so it should go up to 7. So we shouldn't have an 8th index here. So let me, I made this really quickly, so I must have overlooked that. I apologize if you were confused. I'm going to delete this, right? This target is 7, we have to start at 7. Okay, so I'm going to show you how this is going to work, kind of our DP approach, and how we're going to build out basically and find out whether we can create a partition of size 7, or that sums up to 7, right? Because again, we're going to have 2 partitions, right? If we have a 7 for one partition, if we can find that, that means there's also another partition, which is 7, because again, the sum is 14. So if we find a partition that sums up to 7, it means we can return true for this problem. Okay, so see if I can delete this line. There you go. Okay, so the way our algorithm is going to work is we're going to have a outer for loop, right? We're going to iterate through this. We're going to start at this 1, okay? And we're going to have an inner for loop, and we're going to iterate backwards, okay? So we're going to start at target, which is 7, and we're going to iterate backwards to nums minus 1. So nums right now is 1. So 1 minus 1 is 0. So we're going to go from here, from this target, 7, all the way to 0. But remember, it is not inclusive because of how for loops work in Python, right? So your starting position for the for loop is inclusive, but the ending is not inclusive. So even though we're ending at nums minus 1, we're technically not including this. We're going to here, right? So, and it'll make sense because we have, once you see how we're going to handle this algorithm, okay? So the j is going to start here. Remember, we're iterating backwards. This is our inner for loop, okay? And so when we're in the inner for loop at every position in j, we're basically going to check this, okay? We're going to do if the dp of j minus num, right? Now, what is this checking, right? We're checking if the dp of j minus num is true, right? If that's the case, we're going to set the dp of j true, okay? And that'll be useful later on to keep building out this dp array, okay? So initially j is here, okay? So we're going to do whatever j is. So j is 7. So we're going to do 7 minus num is 1. So 7 minus 1 is dp of 6, right? That's false. So we move the j over, right? Because we're in this inner for loop, right? So this j is going to be the one moving for now. So we're going to do this minus 1. Of course, that's going to be false. It's going to basically keep going up until we get to dp of 1 here, right? When we get to dp of 1 minus 1, right? That's going to be 0. So this actually now is going to get set to true, right? Because when we're at this 1, dp of 1, that's a j, minus 1, which is the num, that's dp of 0. dp of 0 is true, so we enter this if statement, and we're going to set dp of j to true, and dp of j is at 1, so dp of 1 is going to be set to true, right? So this is going to change true. Okay, and we're done with this inner for loop for now because we went through it all. That should make sense, by the way, because when we're at this num1, right, of course we can rate the sum 1 from this 1. We can just take this 1, right? We can create a sum of 1. That's like a subset. Okay, so now what we're going to do is we're going to we're going to keep moving forward, right? In this outer for loop, right? This moves forward. Now we're going to go from target up to nums minus 1. So up to 2 minus 1, so that should be 1. So we're going to go up to 1, but again, this is not inclusive, right? Because of how for loops work. So we're going to go actually up to and including the 2. Technically, we're going up to the 1, but it's not including the 1. So technically, we're going up to and including the 2. In terms of how at the end of how far our for loop goes, right? And by the way, it's just so we don't go out of bounds, right? Like if we do dp of 2 minus 2, right? That'll go to dp of 0. But if we do dp of 1 minus 2, right, then we have issues, right? Although I think if you do -1, it goes to the last index. But like if we had like dp of -5 or something, obviously we're going to run into some errors in Python at least, right? Well, in all languages, but I just mean dp of -1 technically is valid in Python. It gives you the last index of the array. But in other languages, that would not be the case, right? But anyways, so j's here, okay? So we're going to do dp of j minus num. So num is 2, keep that in mind. So we do 7 minus 5, right? That's false, so we never enter this if statement. dp of, right, 6 minus 2 is 4, no. 5 minus 2 is 3, dp of 3 is not true. Here, dp of 4 minus 2 is dp of 2, that's not true. Now we go here though, dp of 3 minus 2, that gives us dp of 1, which is true, right? So this has to get set to true now. Okay. Now that makes sense though, right? Because we can create the sum 3 from 1 and 2, right? So of course this gets set to true. That makes sense. Okay. So now we keep moving, right? We go here, right? dp of j is 2, nums is 2, so we do 2 minus 2. dp of 0 is true. Okay, so because dp of 0 is true, we have to set dp of j to true as well. j is at the 2, so this gets set to true. Okay, now that makes sense also because remember, we can create the sum 2 from this 2 that we're on. So that should make sense, right? Okay, now we're done with this outer for loop for now. Okay, and let me just set these to a different color, just a little bit clear, more clear on your screen. Okay, now we keep moving forward in the outer for loop, right? Boom, we go to this 5. Okay, now we're gonna go from this target, and we're gonna iterate backwards to nums minus 1. Well, nums is 5, so we go 5 minus 1, that's 4. But remember, not inclusive. So we're not going to here, we're technically going to, we're going to here, okay? So when we go here, j is here, okay? So we're gonna do 7 minus 5, right? So 7 minus 5, right? Because j is at 7, nums is 5. So 7 minus 5 should give us 2. So dp of 2. Well, dp of 2 is true. So this is going to be set to true. Now, we're going to keep going in our algorithm, but technically we've already solved this problem now because this last index is true. Remember, target is 7, and we found something that can sum up to 7. Which is what, right? Which is this 5 itself and this 2, right? So because these two sum up to 7, this gets set to true. Well, it gets set to true actually because this is true, so that j gets set to true. But you get the point. Like we can use 2 and 5 to create this target 7. And remember, the way DP problems work, or at least in the ones that we're tackling, this one and the previous one, which is word break, the last index is the most important, right? Because that's like the starting index, the 0th index is, or not the starting index, but the 0th index is like the base case, but the last index is kind of where our final, it's basically tracking whether our answer is valid or not, or whether we can arrive at a valid answer or not. Okay, and we can, because we can create the sum of 7. Okay, so we're gonna keep iterating, and we're gonna keep moving in this. Technically, in our algorithm, we're gonna keep going, but we technically did solve it. Just pointing that out. So 6 minus 5 is dp of 1. That's true. So this gets set to true as well. Okay. Now, why is that the case? Well, we can create a 6 from this 1 here and this 5 here, right? Makes sense, right? Just like when we're at the 7, technically we can create the 7 using the 2 and the 5, right? So, yeah. Now we're going to move here. dp of 5 minus 5 is 0, right? So this gets set to true, which makes sense, right? You can create the sum 5 just from 5 itself, so. Okay. Should be done with that. Okay. Now we're going to move here to the final place in the outer for loop. Okay. And so we're going to go from target, and we're going to go to nums minus 1. So nums is 6. 6 minus 1 is 5. So we're gonna go, yeah, we're gonna go to nums minus 1. Nums is 6, so 6 minus 1 is 5. So we're gonna go up to, but not including the 5, because of how Python for loops work. Technically, we're only going up to here. Okay, so j is here. Okay, so we're going to do j is 7. Okay, so 7 minus the nums is 6, right? That's dp of 1. dp of 1 is true, so that means we can enter here and set the true, but we don't need to. That's already true, so it doesn't matter. Right? Because we can create a 7 with this 2 and this 5. So this is already true. But technically, we can also create a 7 with a 6 and a 1, right? So, yeah. So, we're going to move here. Okay. Now we're at DP of 6. And so 6 minus 6 is DP of 0. That's true. So we set this to true technically because we can create a 6 from this 1 and this 5, but technically we can also create a 6, the sum of 6 just from the 6. Okay, so now we're done. We exit this this inner for loop, and of course in the outer for loop we have nothing left. So at the end of this program, we're going to return DP of target, which is going to be DP of 7, which is the last element in the DP array, right? And that's what I'm saying. Like in word break, that problem, and this one, this last element in the DP array is basically what we have to return. If this is true, for example, in word break, if this was true, it means we can create the word from the dictionary of words that were given. If you've seen that problem. If you haven't, it's okay, but feel free to go visit it. It's very similar to this in terms of the approach. In this problem, though, this last element, right, is important, and we return it because if this is true, right, because we're just returning whatever this is, what's in here, false or true or false. We don't care what's in there. We just have to return whatever this is because this is a correct answer, right? So if this is true, it means we found a sum that adds up to target. So it's set to true, so we're just returning this. Now, if we couldn't find anything, of course, this would be false because remember, we initialized it as false. And so in that case, we couldn't find a target, or we couldn't find any subset that adds up to this target. Okay, so that's kind of how we're going to solve this problem using DP. Okay, so now I'm going to show you how we're going to code that up. Okay, we're back here in Python. Okay, so remember what we did before, right? We take the total sum. I want to say sum of nums. I'm just using a built-in function. I don't want to write a for loop, but I mean you can do it however you want, depending. You know, some interviews won't let you use built-in functions. I guess it just depends on your interviewer. But remember, this total sum, if it's not an even number, then we can't really partition it, right, into equal subsets. Or into two subsets that the elements sum up to the same number in both subsets, right? So for example, remember, in case you forget, right, like if we have a sum that adds up to 7, how can we ever have two subsets that are equal to each other in terms of the sum if we have something like 7, right? Because if we have to split it into two subsets, right, you can't do that with an even number or with an odd number. So if total is an odd number, we have to return false, right? Okay. So now the target, remember how we get the target? We just take the total and we divide it by 2. Okay. Okay. Now this is where we create our DP array. Remember, our DP array is false initially, and the length of it is going to be target plus 1. And remember, we have to initialize the base case, which is 0, the 0th index, and we set that to true. Right? This is just the base case. The sum of 0 is always possible with no elements. Okay? Right? And let me just add this comment here, right? The DP of I is basically saying true if we can form the sum I using some subset of nums. Okay? Now here's what I'm saying, like this is the outer loop that I was talking about. We're iterating through nums, right? So for num in nums, right? And remember, we have an inner loop, which is the j, right? And remember, we're iterating backwards, and we're starting at target, and we're going to nums minus 1, not inclusive, remember that. And then this minus 1 here, because we're going backwards, right? So remember, if dp of j minus num, right? If that's true, then we set dp of j equal to true. Okay, and that's it. That's how our algorithm works. At the end of this, right, if the last element is set to true, we're going to return true. If it's set to false, we're going to return false, and that should give us the right answer. Whoops. Let me see what I did. Oh, I said nums. I meant to say num. My bad. Okay. Now, I know this video might be slightly long, but I hope you can appreciate the illustration just because, like, I feel like this is hard to visualize in your head what's happening exactly. So I just want to go through the illustration and go through the problem by hand. I hope you can appreciate that. And I hope this kind of more optimal solution made more sense. This is probably what they would expect of you in like an interview probably. I think the set solution would probably be okay too, but it depends. Like if you have a strict interviewer, they might actually want like a DP implementation where you actually use like a DP array and stuff. But yeah, you have two ways to solve it. Depending on what you want. But I hope this helped, and I'll see you in the next one. Peace out.